Good evening, everybody. Well, we're going to take a look at identifying the independent and the dependent variable. That's important because the independent variable needs to always be in the x-axis, and the dependent variable always needs to be for the y-axis. After we've done that, we're also going to learn to write a function rule to go along with the scenario. Again, if you don't know which is the independent or dependent variable, then it's very hard to write the function that goes with that, because we need to know which is x, and x belongs always with the independent variable. So with that said, let's get started tonight. Okay, so let's take a look at how we find the independent and dependent variable. First of all, you'll see I've already put a graph up here, y being my dependent variable and x being my independent variable. And so we have this person, Mr. Ocha, who is the debate team coach, and he's organizing a debate tournament at his school. The number of rounds in the tournament will determine how many volunteers he will need as judges. So I want you to use this technique. I want you to write the word depends. And then I want you to read the statement of the two choices that you have between being independent and dependent. The number of rounds in the tournament depends on the number of volunteers that are judging. Okay? The number of volunteers needed depends on the number of rounds in the tournament. So which comes first? Which did we decide first? The number of rounds or the number of volunteers? Well, I think in this case we're saying that they decide how many rounds, and then they go out and they find out how many judges. So the number of volunteers needed for judging depends on the number of rounds in the tournament. So which is the independent variable? The independent variable is R, the number of rounds, and which is the number of volunteers? V is the dependent variable. So as the number of rounds increase, the number of volunteers needed for judging increases. Right? So once we have that, it would be quite easy then to write an equation that matches that information. So we'll have more practice with that on Monday, but if you can use that as the technique, which comes first, the rounds or the volunteers? Okay, so let's move on to another. Okay, so here we're going to identify the dependent, independent variable, and this time we're going to write a function rule for the situation. So a zoo charges $6 for parking and $17.15 for each child. And they want us to identify the dependent and the independent variable. So the cost of admission depends on the number of children. So which one is the independent? Well, the cost depends on the number of children. So the cost is up here, and the number, and let's see what else we got here. Oh, and x is the number of children. So once we know which is the independent and the dependent variable, we can choose to bring as many children along as we want, but that will increase the cost. As we bring more and more kids along, the cost will increase. So it says here that I pay $6 for parking. Well, if I don't bring any kids along, I still have to pay $6. It also says that I pay $17.50 for each child. And we said that children were X, so I'm going to put 17.5X. And we're supposed to write this in function notation, so I'll write f of x equals 17.5x plus 6. And then it says to evaluate when x equals 4. So that's just asking when we have 4 children, what do I do? Well, I do 17.5 times 4 plus 6. So what's that? 17.5 times 4, 3576, I believe is the right answer. So when I bring along 4 children, my cost is $76. When I bring along 10 children, my cost, let's see, 17.5 times 10 plus 6, 175 plus 6, 181. So my cost for 10 children is $181. So as you can see, it's very easy to set these up. We will do one more example here, and then we are done for the evening. Okay, so here we have a table, and they asked us to write a function to match the table. In other words, they want us to have f of x is equal to, and what equation would generate these numbers. So when I put in f of 3, I will get it to equal 16. When I put in f of 4, I need it to equal 19, and so on. So let's take a look at this. As x increases by 1, what happens to my y? Well, it increases by 3. So that's saying that every time x increases by 1, I multiply my answer by 3. Hopefully you can see that. I look here, and every time my x increases by 1, my y value increases by 3. So if my x increases by 1 here, I just multiply it by 3. So 3 times 1, 3 times 2, 3 times 3, and multiplying the value by 3. So let's go back. Now we have 3 times 3 equals 9. 9 plus something has to equal 16. 3 times 4 is 12 plus something has to equal 19. Well, 3 times 3 is 9. 9 plus what will give me 16? Hopefully you can see that is 7. 12 plus what will give me 19? Again, it better be the same. So I now know that in order to see my function, I have 3x plus 7. So I'm going to check my function really quick. I'm going to use f of 5, and I'm going to go 3 times 5 is 15, plus 7 equals 22. My function checks. Let's have you do one for practice. I'll put up the table. You practice it, and then if you can bring the answer in tomorrow, we'll see how you did. Okay? Okay, so the first thing we're going to do is take a look. Is my values increasing or decreasing? Well, here it appears that every time my x increases, my y decreases. So my f of x looks like it's going to be -4, -4, -4. So I'm going to write -4x. Okay? And then I'm going to say -4 times 4 equals -16 plus some number is going to equal 18. -4 times 5 equals -20 plus some number equals 14. So what do I have to add to -16 to get to 18? Well, 16 plus 18 is 34. -16 plus 34 is 18. -20 plus 34 is 14. And then we're going to check it. So f of 6 is equal to -4 times 6 plus 34, and I hope that equals 10. So -24 plus 34 equals 10. 10 equals 10. And we'll have more practice. So my function is right here. But we'll have more practice with that tomorrow, but that's how you check. Obviously, you can do it the hard way with guess and check, but that's the easiest way. What is my constant change here? I'm decreasing by 4. That's what I'm going to multiply by, and then I have to go back in and figure out whether I'm adding or subtracting. Hope you have a good evening, and we'll see you tomorrow. Bye-bye.